Okay, so just going to get things started here in this video presentation. We're Cloud Computing Team 18. My name is Damian Sandhu-Franceschi. The group member presenting after me is Jordan Camirand, and the group member presenting last and doing the demo, which will be attached to this video, is Daniel Kolodziejczak. They will introduce themselves later just to make sure that we don't confuse you, and all our names are in the bottom right-hand corner all the time. So what is our project? Well, it's simplifying web application deployment and maintenance by using the cloud. What does this mean? Well, we'll get to that in the next slide. Next slide, I'm just going to look at the project statement here. So what is our project idea? What did we want to do? Well, we wanted to determine the best deployment option for a web application called Curate. Curate is an application that one of our group members, Daniel, created last semester for a group of his in a course. And it's just a simple application that has a React.js front end on Node.js with a Python Flask backend. We wanted to use this application since Daniel was very familiar with it. It was simple, easy, so we wouldn't run into any issues with the software. And if we did, we had someone that was very knowledgeable about it to debug the software. So really the only issues we should potentially run into would be within the cloud services themselves. Our cloud services that we're going to look into actually were only AWS and Azure, just because that's what we focused on all term, and we didn't want to make the scope of this project too large. So how are we going to determine the best deployment option? Well, we want to determine it based off 6 criteria we came up with. These 6 criteria were how easy it is to redeploy the application, are there integrations with the source code repository and versioning, are there ways to minimize downtime if the application were to go down, how easy is it to set up the public domain within these services, is there any cold start time associated with loading the web page for infrequent access, and is the cost of the solution reasonable? This one's obviously a major one. You don't want to host a simple application on something that's going to charge you $50 a minute to host it on. Alright, so next slide. We're just going to get into the contributions here. So, contributions. Well, what did we do? What did we actually find out? Well, we found out that AWS Amplify Console for the front end, AWS Elastic Beanstalk for the back end, and AWS RDS was the best combination solution for hosting this web application based on our 6 criteria. Obviously, in different scenarios, maybe different applications, different solutions might be preferred. We actually stayed away fully from doing any manual hosting solutions such as Amazon EC2, just because we wanted a simple, easy solution that fit our criteria and provided a whole bunch of features for the user. We'll get into this more later, but just thought I'd mention it now. So why should you care about this? Why do you care? Well, it's always good to know what options are out there when it comes to the cloud. Thousands of developers every year are dealing with cloud services. This is a growing industry. People are using it all the time, and hosting is a major area within that. So we're hoping that this presentation will help inform you in choosing cloud services in the future. It'll help you make informed decisions on which ones will save you money, hours of debugging, management, which ones provide you the most features. So we're just hoping to inform you here so that in the future, if you need to host something in the cloud and work, or on a side project in a startup company, you know which cloud hosting services are out there, and you can make an informed decision as to which one you should use for your application. Okay, so now we're just moving on to cloud aspects. So, what are our cloud aspects? Well, AWS. Within AWS, we originally were going to look at Amazon Lightsail. Unfortunately, we had to drop this solution because of us only having student accounts. We weren't actually able to access it. So the only Amazon solution we ended up looking into was this combination one of AWS Amplify Console for the front end, which is a product as a service, and it's simple deployment of front end applications. AWS Elastic Beanstalk for the back end, again, product as a service, simple deployment of web applications, the back end, and AWS RDS, just a database service, simple deployment of relational databases. So these are the cloud services we looked into. Not going to bore you with a full tutorial how to use them, but that's just the basics of what they are. If you want more information, feel free to read our report. So next slide, just going to move on to Azure. So within Azure, we only looked into one solution. Like I said, we avoided all manual solutions. We didn't want to start up a VM and do all sort of manual processes since that kind of went against our 6 criteria of making things easy. So within Azure, we looked into Azure App Services, which actually provides functionality. It's a product as a service again, but it actually provides functionality for deploying the front end and the back end within the same service. However, we did not deploy them within the same deployment. They had their own, we had a front end deployment and a back end deployment that interacted with each other. And for the database, we used Azure SQL databases. Simple database service, just provides simple deployment of relational SQL databases. Nothing complex. They're very similar to the AWS RDS service, but just a bit different in how they implement them and etc. But at the base level, it's just an SQL database.
All right, thanks Damian. My name is Jordan Camirand. I will be taking over for the next several slides. So what did we learn along the way? What was the output after all this time, research, and deployment? In this section, we're going to go into more detail about all of our findings and some key concepts that assisted us. Next slide. First, IaaS, or Infrastructure as a Service, versus PaaS, or Platform as a Service. Right off the bat, you can see that with the help of this diagram, with Platform as a Service, you manage less things. To clarify, the blue is what you manage, and the red/orange color is what the cloud provider takes care of for you. So the main advantage of using a complete Platform as a Service solution is that you get to leverage the cloud a lot more and set up less things yourself. This includes continuous integration, monitoring logs, and build support right off the bat. The downside is that it requires more cloud-specific knowledge. For example, in AWS, our application required 3 different products, one for front-end, back-end, and database. Azure was only 2 products, since the front-end and back-end were handled together, but the point still stands. The Platform as a Service solutions were also more expensive, which depending on your criteria can be a big factor. The Infrastructure as a Service solutions, on the other hand, by nature require less cloud knowledge because they are simply providing you the infrastructure. After you get the VM from them picked out and set up, there's very little extra cloud knowledge required. But the downside is you do have to set up all those features that already came right out the box with Platform as a Service. The other 2 extremes we won't really cover in depth, but we'll talk about a little bit here, are premise solutions and software as a service. Software as a service is simply an application that you don't manage, for example, Dropbox, and on-premise is just the old-fashioned where you manage everything, including networking and hardware. All right, next slide. So to summarize, Infrastructure as a Service solution provides cheaper solution that requires less knowledge of cloud-specific products, thus enabling you to be less coupled with a single cloud provider. The downside is that you have to set up more things yourself, and it'll be harder for you to monitor and manage your application. You technically can pull off anything done with Platform as a Service solution with Infrastructure as a Service, but the key difference is the time and effort required to do so. Platform as a Service, on the other hand, provides a more complete out-of-the-box solution. This enables you to spend less time on setup and more time on the application itself. On the other hand, it requires more cloud-specific knowledge, and you will be tied to your cloud provider. Also, from our research, these solutions do cost more. We ultimately decided to go with a Platform as a Service solution, as based on our criteria, we really value the convenience and time saved. Next slide. When we decided on Platform as a Service solution, we then moved to comparing the required services from each provider. As you can see here, AWS is cheaper, and from our own research and experience, has better documentation for our needs. This was important to us as convenience and minimizing time to deployment was part of our criteria. The backend for AWS with Elastic Beanstalk did prove to be the most expensive part, but it does support a lot of nice features such as load balancing and others. So after using both of these, the AWS service we were more impressed with, and ultimately that's why we decided to go with it. So next up, we'll be talking about some helpful resources that could help anyone interested in learning more around this area. First off, we have a really good blog post about the differences between the 3 main types of cloud services. So again, that's Infrastructure as a Service versus Platform as a Service and versus Software as a Service. So we didn't go into Software as a Service much into this presentation, so it'd definitely be good to learn more about it through that nice blog post. Next, we have a tutorial on deploying a backend to AWS Elastic Beanstalk, which is what we used. And this one is specific to our tech stack as well. So this is a tutorial on how to do and set it up with Python Flask. Next, we have a more general tutorial on deploying and connecting to a Postgres database, which differs from what we've learned in class because we're using the NoSQL one in class. So this is a SQL database. And finally, we have a nice general overview of AWS Amplify and how to use that.
Thanks, Jordan. I'll take it from here. I'm Daniel Kolodziejczak. I'll be finishing up the slides and showing the demo. If we had to do this again, next slide. We put our focus on exploring platform as a service options for this project. If we had to do this again, we would definitely still put effort into exploring these services because they enable simplified deployment and maintenance compared to just using infrastructure as a service. Although infrastructure as a service has some benefits over locally hosted solutions in terms of availability and reliability, it still takes as much manual effort to deploy and maintain an application as for any other server. For example, the AWS Amplify console could easily connect to a Git repository without needing to worry about the underlying infrastructure apart from OS and runtime. And Elastic Beanstalk ensures that the web application scales to meet the demand that you configure by provisioning all the resources you need, along with good defaults and handling the deployment of new versions for you. Also, we found that trying to deploy parts of the app to a similar service in a different platform when we ran into issues helped us to identify solutions to problems we ran into, and learning would carry over to the other similar services that we tried, such as the need to have the configuration files for the front end of our application in the root level of the directory for Azure App Services, which helped us to resolve issues with deploying using AWS Amplify console. For future projects, we would make sure to have self-contained repositories for different parts of the application prior to attempting deployment, as that helps to better isolate and understand the requirements for the deployment of each separate component, and should make the maintenance of these components easier. We could also consider serverless architecture for new projects, as that is unique to the cloud and could be an easier way to develop and maintain applications. For example, AWS Amplify offers a way to build parts of your web application technology stack using their CLI, which could reduce time needed for development. And because it is integrated with their service, it could make the workflow for deployments easier as well. A cool feature that Amplify offers that would be worth looking into if we were to use the Amplify framework would be synchronized deployments of both the front end and back end of the application, which would ensure that there are no mismatches between the API and the client accessing the back end. Additionally, it would be worthwhile to go more in depth on any other useful features that are offered by the services that we use, such as integrations for code reviews or other means of configuration for managing the build and deployments of applications. Furthermore, any opportunities to automate deployments beyond the continuous integration features we found for the front end could have been also explored. It would also be interesting to explore more service offerings, such as trying AWS Lightsail outside of the AWS Educate account, to see if it was a more effective solution for deploying a web application based off of our criteria. On top of that, it would be good to explore how the features of similar services differ across other platforms that we didn't try, like Google Cloud or Heroku. Next slide. And now we'll show you a demo of our application in AWS, and where we used the AWS Amplify console for the front end, Elastic Beanstalk for the back end, and RDS to host our database. Alright, so to start off, let's take a look at our database, which we have deployed in Amazon Web Services Relational Database Service, or RDS for short. So here we can see just a dashboard of all of the things we have using RDS. Here are all our database instances that we've created. We've only created the one Curate database for our application. If we can click on it, we can see more details about this database instance that we've deployed, the endpoint and the port we want to listen on, the security groups that it's a part of. Here it's available to all incoming traffic. And we also made it publicly available here so that we could access it. There's also other tabs like monitoring, logs and events. So here are some error logs, configuration for more details, maintenance and backups that happen every 7 days. And that's all taken care of by the relational database service. And here we can see we can click modify to change any properties of our database deployment, such as multi-AZ deployment, have it deployed into another availability zone, storage type, networking, so especially the security group is important, and then backup time frame, and some other details here. So using this endpoint under connectivity and security, we can connect to our database, and if we use pgadmin as just one tool for connecting to your database, for a Postgres database specifically, we can see if we make a query on our tables, For the category table specifically, we see all the columns there, and down here we can see all the tables required for our application. So moving on, we have Elastic Beanstalk to deploy our backend, and which allows us to make requests to our database and give back that information to the front end. So here's our dashboard. We can see the running version as well as the platform we're running our backend application on. Here are the most recent events that occurred. It says we transitioned from severe environment health to OK, which is a good sign. Or here it's saying, here before it was 100% of the requests were erroring at as 400 errors. But let's see some other things. So under configuration, we have environment variables that we've set up. Especially important was the whiskey path. If by default it's application.py, but here we have our app that uses run.py. Instances that we're deploying, capacity, how much it can handle in terms of auto scaling. So here we see a max of 4 and minimum of 1, and it'll scale as needed. What type of load balancer are we using, as well as some other details down here. Let's take a look at the health section. So here we see we have one instance of type t2.micro, and its status is OK. It's been running for 3 days, and it's our 53rd deployment. And it gives us some other stats here, like percentage of idle time, as well as some other things here, like latency, and then what kind of requests are we giving responses to. So 400 errors or 500 errors, or are we returning OK? So let's try deploying here and see how easy it is to deploy using Elastic Beanstalk. So all we have to do is click or type in ev deploy, and we can see it'll just generate the events that we saw earlier in our dashboard, such as environment update starting, and it'll tell us, yes, now it's deploying new version to our instance. We saw this is actually refreshing automatically every 10 seconds. So we can see it's pending an application update. That's going on in the background. And now it's saying it was successfully deployed. So let's just see what it says once it's refreshed. And now our application's deployed. So let's say we go to our backend URL that's provided for us by Elastic Beanstalk. We can see Hello World on this page. But let's say we go to /categories. We actually see we get this response of the data in our database. So lastly, we have Amazon Amplify console. Here we can see all our applications that we've deployed. Here we have Curate, which is our front end. And we can see under the master branch that we've configured to build on every commit. We can go back in time to earlier commits or earlier builds, but the most recent one is build 35. You can see everything was successful. And we can also see logs of what was going on in order to actually deploy our front-end application. Here we're provisioning the environment, or the resources needed to run our application. And then we have building, which was cloning from the repository, and then generating our web page here, all the files we need. Lastly, deploying, so it actually copies over all those files from a temporary location. And then we can see here, it actually gives us an example of how it would look for different browsers. So Google Pixel, iPhone 8, etc. If we go to this link, we can see the sign-in page, and for example, we can go to our sign-up page so we know routing is working correctly. And we actually had that set up here with rewrites and redirects, so that any path that matches this path will rewrite to with the status of 200 to index.html, because it's a single-page web app. Our app specifically is using React. Just to take a look a little further, here's where we configured all our build settings. So how to install, we can see npm install, and then here we also ran npm run build to actually build our application.